Hello everyone, I'm Doria, and welcome to this openEuler mini course. Today I will talk about the I/O performance analysis and troubleshooting for a Linux distribution. I'll introduce two I/O tools, IOstat and blktrace, describe how they work, and describe how to use them for troubleshooting. Help you find the course both useful and interesting. I/O stands for input or output and refers to the communication between the computer and the outside world, whereby data is transferred to or from a computer's central processing unit, CPU, or memory. Input devices include keyboards, mouse devices, and microphones, while output devices include monitors, printers, and speakers. The I/O process is crucial for allowing users to interact with the computer and for enabling programs and systems to operate and communicate with each other. This means it's essential for I/O problems to be found and resolved immediately. The question is how to do so. Fortunately, there are some efficient tools for I/O analysis. First up is IOstat, a performance monitoring tool used to display the usage of system drives and CPUs. It is a command line utility built in Linux distributions that checks the I/O subsystem activity of computer systems. It outputs drive reading and writing speeds, the average response time of drive I/O requests, CPU usage, and other important metrics used to evaluate computer system performance. IOstat mainly focuses on the whole I/O performance of a drive, requiring another tool named blktrace to analyze the performance of a block device. blktrace is a tool that analyzes the I/O performance of a block device, providing more detailed data of each drive operation, such as execution time, queue depth, read or write size, and request sequence. Similar to IOstat, the tool is used for monitoring drive I/O performance. IOstat is primarily used to monitor overall system drive I/O and is suitable if you need an overall view of your system's operation and to analyze system bottlenecks. But if you want a more detailed view of the I/O performance of individual block devices, blktrace is a better choice. Typically, blktrace is to supplement tools like IOstat to provide more in-depth analysis. These tools can quickly identify system bottlenecks and provide optimization means to improve system performance and stability. Now we've given a background to both I/Os and analysis tools. Let's explore the working principles and usages of IOstat and blktrace. IOstat reads information through APIs provided by the kernel before calculating and outputting the information. Some APIs are displayed here. The first API reads the number of I/Os. By calling it, IOstat outputs the number of read requests processed per second. The second API reads the number of combined I/O requests, and by calling it, IOstat outputs the number of read requests combined per second. In this way, IOstat obtains the listed information from the kernel as required. To use an IOstat tool, run the IOstat command. By default, the tool displays statistics for all available block devices. By adding an option to the command, we can specify the type of data to be displayed. On screen, you can see a list of options. We can also specify the devices for which we want to display statistics by providing device names for IOstat. For example, the displayed command in the first line will display statistics for 2 block devices. By default, IOStat displays one result at a time. It can also display results constantly and set the output interval by specifying the number of seconds between updates. For example, this command in the second line will display I/O statistics every 5 seconds. As for BLK trees, it is divided into kernel and user space components. The user space component of BLK trees receives a list of desired devices and passes it to the kernel. The kernel's trace points at the block level then start working, passing the relevant data to the user space component, which writes the data to the drive for analysis. This tool needs to be used with BLK parse, which parses the binary data generated by BLK trees into a readable format. Similar to IOStat, BLK trees can also be followed by different options to execute various functions. Some common options are listed here. To obtain the I/O saturation of a certain device, we can run the command listed here. The output data can be redirected to BLK parse for real-time parsing. The lower command on the screen tells BLK trees to write to standard output and BLK parse to read from standard input. The default output format is displayed on the screen, which includes the primary and secondary device IDs, CPU ID, serial number, timestamp, location in the I/O path or the action, and I/O type. Additional information will be output or not based on the I/O action. Generally, additional information includes the I/O start address, size, and process name. Okay, let's take what we have learned and use the two tools for troubleshooting. For an XFS file system with 64 KB page size, we set the size of each I/O block to 4 KB. However, the output shows the data size written per second is 2 MB, far larger than our configuration. To check the issue in a more detailed way, we can use the BLK trace tool, the results of which are displayed on the screen. Here, the numbers 8, 16, 24 on the right indicate the number of I/O sectors. As the size of each sector is about 0.5 KB, we can find that in the first result, the delivered I/O matches the size we defined, but later the I/O size is increased by 4 KB each time and surpasses the desired size. From these results, we can conclude that the issue comes from the XFS file system, which does not support subpages and thus delivers I/Os larger than 4 KB. This concludes our course. You can find the openEuler kernel repository on Git and join our community discussions by submitting an issue. Or you can send us an email if you have any questions. We hope you find it enlightening, and if you did, remember to follow us on our socials. We'll see you again in the next openEuler mini course. Thank you for watching.